see. Yeah, the one in the waiting room. Okay, we can move forward. We are online on YouTube, and Facebook is still sending data, but it doesn't matter. YouTube is more important. Okay. Okay. So, what is this document? The idea is the following. I'm gonna make brief notes here about each lecture, but sometimes, and when I'm teaching, it's okay, I can do that directly here. But while another invited speaker is talking, sometimes I'll be able to write something, or sometimes I will not be able, because I have to pay attention to what the guy says, and also take a look on what you are doing, and also I have to think about to ask later. So sometimes I won't have room enough in my mind to write the notes. So everyone is invited to add notes here. So everything that people is talking during the lecture, everything that you think that is important, you can just write it down here. And this is gonna be available to everyone. So a kind of a collective notes. It's been working nice with my undergrad students because for example, because I said today I will show kinematics in a different way you all are used to. Okay. So everyone will be well, I think that the motivation is that having all of us putting all our notes, our ideas, our perceptions about what people are talking about, what people are teaching to us within a same document will be best for everyone. Will be the best for everyone. So that's why we are doing this. I'm gonna try to show kinematics to you in a way that is not the usual way, because the usual way you learn kinematics in biomechanics is, I would say, low level biomechanics, or at least no more than that high school level biomechanics. It's not a real adult age biomechanics. So it's for teenagers. So let's start. But today is I'm sorry, today is exclusive for teenagers biomechanical. No. What I'm gonna do, I'm gonna show you what is the real biomechanic, real kinematics explanations. Okay. That's what I'm going to say, because, well, you will see the difference. You will see now the difference. Thank you. No problem. And be very, very. Anytime you want to stop me, it's just stop me and ask me. Okay. So, and I think that what I'm gonna show you is gonna help you to understand these two first chapters of this book. Okay, this is one very nice book in biomechanics. Research methods in biomechanics. So you have all these authors here, and Professor Joseph Emil gonna be with us. Joe gonna teach something with us to us, and our lecture today is dedicated to give you basis to understand chapter 1 and chapter 2, which tells you about kinematics. So and after that we are gonna do similar things for kinetics, and I'm gonna give you things, I'm gonna teach you things to understand what is written here. My suggestion is to read all this book to understand, and this is basic biomechanics. This is basic biomechanics. Okay. Basic biomechanics for a graduate student. For graduate student. Okay. For undergrad, okay. If you don't know all these books, okay. But if you are a graduate student, and you want to go deep into biomechanics, you need to know all this book. You need to know all this book.
Muito bem, tudo bem?
Pessoal,
Okay.
obrigado, viu, pela...
Tudo bem? Olha o chamego aí. Se eu vou posicionar a preta azul, você preta azul. Não, tem não. Eu quero que os caras...
Okay, would be possible to mute all the participants?
Yeah.
Because some of them are keeping the microphone.
Ricardo, you should do this for me.
Who is the person, please?
You just you just need to oops. Oh, I have muted you as Ricardo. But anyway, you just need to look at the participants, and if you see some mic open, you just go there and close. You don't need to ask. Okay. With the co-host power, you can do this. Thiago, I'm gonna give you also this superpower. Thiago Teruya. So then you also be able to. And Ricardo, both Ricardos. Okay. So you can help me handling with people in the waiting room, and if it's someone for any problem, forget about turning off the mic. Okay, so this book is nice, and I'm gonna give you the basics to understand the first two chapters. That's the goal for today. And I will try to do this as short as possible. Okay, that's another goal. So let's return to our notes. Kinematics is a branch of mechanics concerned with the description of motion. Okay? So I just want to describe the motion. And to describe the motion, I'm used to use the kinematic variables. So position, velocity, acceleration, orientation, trajectory, and so on. So that is easy, and all students, high school students, know that. But what high school students doesn't know about this is the real difference between 2D and 3D kinematics. Why? Because in 2D kinematics, in 2D kinematics, two variables are necessary to describe, and in 3D kinematics, at least three variables are necessary to describe the motion. So it means that, for example, I want to know the position. I want to know the position. So I want to know the kinematics. I want the position of the end point of my arm. Okay? So I want to know the end point of my arm. Usually you think, okay, which are the variables to do that? You will say, the coordinates x, y, and z, right? And if it is on a plane, you're gonna say, we just need two variables. You need x and y. Yes, that's the common idea. But in fact, when I have another option to have the same information about where is the end point of my hand, of my arm. If I know the angle of my shoulder, and the length of my arm, I will also know where it is the end point. And in fact, if I consider that my elbow never flex or my wrist never moves, in fact, I'm gonna need just one variable to describe in a two-dimensional space on a plane where my arm is, my end point is. So when I say two variables, it doesn't need to be x and y. Can be any two variables to describe the motion. But we are used to think about coordinates x, y, and z because we are used to think about the Cartesian reference of system of reference. Okay, so let's think about coordinates on a map. Coordinates on a map. When we are thinking about a map, we are not thinking about x and y. So let's say São Paulo. We are thinking about two angles. We are thinking about latitude and longitude. It's taking too long time. So this concept, it means that for me to describe when people say 2D kinematics, means that for you to describe the movement, you need two variables. Sometimes the most common way to think is, for example, how high or how tall and how large or how wide something is. Okay, so x and y, that's what I used to think, and we are pushed to think. But this is not this is a very simplistic way to think like this. When we talk about 2D kinematics, we need to think about two variables that can describe the motion. So sometimes two variables can be these two, and so we need two coordinates. But sometimes these two coordinates can be, in the Cartesian system, x and y. But sometimes can be one number and one angle, or even can be two angles. Okay. So this is very important to understand, because when we read biomechanics, we are not going always to see people talking about kinematics in terms of x, y, and z. They're gonna talk about three variables, and thinking about, okay, then if people say 3D kinematics means that you need three variables to describe the movement. Sometimes those three variables can be two angles and one length, for example, or can be well, let me draw you. Let me draw. Now, let me see if it works fine. Okay, yeah. So, for 2D kinematics, you can see something like this. If dot here, so x and y. But so these are the coordinates, okay, x and y. But it can be also something like this. Here the position, okay, can be angle and length. It's the size of this line. With these two options, x and y, or angle and length, I can have the same information. What is the information? Where is the endpoint? Any question?
Yes, if I may. Is time an important variable in describing motion, or actually for biomechanics it's irrelevant?
No, time is important. Time is important. But when we are thinking about kinematics, when we talk about the variables, we are not considering time.
Okay, thank you.
Because then there is a special definition for that. Because when you consider time within your variables, for example, you can have a trajectory, because then you have a set of positions. Then you have a trajectory. Or when you have motion, for example, when you have velocity, when you have acceleration, then you are considering time. But in terms of motion, in terms of describing the motion, because, for example, if you plot something like this, okay, this is time and this is x, okay, then you have this. This is not 2D kinematics, okay? This is not 2D kinematics. This is kinematics, but this is not 2D. And you don't know if it is. This is just one dimension kinematics, because you have just one variable that counts for this, 2D or 3D. So no. I need something better than this to write. But no. Oops. No 2D. Awful. Sorry. But this is not 3D kinematics or 2D kinematics. This is just one dimension kinematics. So this is very important. Because using x and y, or L and theta, or any other thing to describe your motion, all these solutions, they are equivalent. So they are equal. I'm gonna show the same thing for, oops. Oh. Yeah, I have to erase. But okay, could you get this explanation? And let me show you for the 3D kinematics. So for 3D kinematics, then we have 3 axes. So the common way is, for example, x, y, z. Z is awful. So then you have this, and then you have these coordinates, x, y, z. Sorry. but you can also show this position using this description. I'm doing just so. We can use this angle, let's call alpha, and then we can use this angle, let's call beta, and then we can have this length. So if we want to know something in the space, within this 3D space, we can use the common coordinates x, y, and z, but we can also use two angles and one length. Okay, and in fact we can have we can use a different combination of variables to describe the same movement. So this is equivalence. So it doesn't matter this is one reference system 1, and this is reference system 2. Okay, so you can describe the movement using the reference system 1 or the reference system 2, and those two are equivalent. It means that they give you the same result. They can show you where something is in the space. And okay, and this is quite interesting because erase everything. Okay, and later that you can take everything. So for example, when we are in 2D kinematics, we can have this equation: x is equal to the length multiplied by the cosine of the angle theta. Because when you calculate the cosine, you have the adjacent side of the triangle, and when you calculate epsilon, you have epsilon is equal to the length multiplied by the sine of the angle. So always, so when we are doing 2D or 3D kinematics, we can have different reference systems to describe the motion. So that's the real meaning of 2D or 3D. So 2D means I need two variables to describe, two dimensions. So dimension, the idea of dimension is how many variables you need to do something. And something that is in many cases it is the case that if you have more variables, then you have a system that is more complex, but it's not always the same. It's not always, this rule never, it's not always right. But usually if you increase dimension, means that you are increasing the complexity of the system. So 2D kinematics means you need two variables to describe the motion. 3D variables means that you need three variables to describe the motion. And I told you that those variables, those reference systems, they are equivalent. So it means that they give you the same thing. It means they give you the motion. So if I use X and Y, or I use angle and length of some of my arm, they give me exactly the same thing, the position of my end point, the position of my arm. Okay, so turning that into mathematics, it means that there is equation that you can use to transform one reference system to another reference system. So to transform a reference system to another reference system, we need the equations to associate one set of variables to another. So let's say, example, and then I'm gonna here reference system. Okay, so reference system 1 is the Cartesian system, so X, Y, and Z. S2 is the polar system, so only X here is the polar system, so it means theta and L. So these two are the transformation equations for us to understand. Okay, so if you apply this equation, if you know theta and you know L, then you're gonna know X. This is what we call the importance of transformation equation. So transformation equation is a formula, an equation that takes you from one reference system to another reference system. And 2D kinematics is the kinematics that you need two variables to explain or to describe the movement. And these two variables can be anything that you like or anything that you can measure. You see? You can do, and this is something that we learn not at the school. We learn at the college. We learn that when we are doing our mathematics or doing physics, or we are doing some or mathematics, when we are doing calculus. No, calculus. Yes, when you are doing calculus, because you learn algebra when you are doing algebra and calculus. No, more than that. When you are learning mechanics, because when you are learning mechanics, then you have to learn to know about calculus and algebra to really understand mechanics, and then you will go to what we are going to call generalized coordinate system. What is the generalized coordinate system? Is any coordinate system applied to describe the motion. And then we have generalized coordinates that we are used to call as I, J, and K. When we are dealing with 2D kinematics, then we have only I and J. And when we are doing with 3D kinematics, then we are dealing with I, J, and K. But if you are doing with 4D kinematics, then you have I, J, K, and WV, for example, and so on. So generalized coordinates means that is any coordinate. Doesn't mean that it is Cartesian system, doesn't mean it is a polar system, helicoidal system. It doesn't matter which system is. So that's something important, because when you are learning biomechanics and people say, oh, that's the most important equation, Newton's law, yeah, F equals to m mass multiplied by acceleration. Yes, you're right, this is something very important, but it works only for the Cartesian system. Because for example, if we go to another system, this equation has to be written in a different way. Because then, for example, then we have to add cosine, we have to add something, a lot of things different from here. So this is nice, but this is high school biomechanics. X and Y, it's nice, When, for example, you take a picture, then you trace the coordinates, and then you calculate, okay, this is the coordinate, okay, this is high school biomechanics. The real biomechanics is generalized coordinates. And if you understand this, then you can start to understand what is written in the first chapter of this book about kinematics. Okay, so when they are explaining 2D kinematics, we are used to think about these reference systems, and because that's the easiest way to do. But it's not the only way to do. Maybe it is the easiest way to show, but never it is the easiest way to calculate everything. So, and then we have something that is very important, that what we call degrees of freedom. So degrees of freedom, in other terms, it is the number of dimensions that you have. This is for one body system. But when you have a multi-body system, so each part of the system needs new coordinates. So degrees of freedom is the number of variables that you need to describe a motion. Okay? If you think something in space, for example, this sphere, this glass sphere here, you can see or you cannot. Yeah, sometimes you see, sometimes you don't. But it is a sphere here. But for example, if you have an object, this object, you need 3 coordinates in space. So you need to define it in space. You need 3 variables in space, and also you need to describe the motion. But these 3 variables can also need to be describing according to their rotation, because motion can be translation or rotation. So it means that for you to describe the motion of this object, you need 6 variables. So if you need 6 variables to describe something, means that you have 6 degrees of freedom. 6 degrees of freedom. Okay. In biomechanics, so up to now, 2D kinematics means you need 2 variables to describe the motion, and 3D kinematics, you need 3 variables to describe the motion. At least, as I said, at least. And the most broad term for everything is generalized coordinates, because if you say generalized coordinates, you don't care if your coordinates are x, y, and z, or angles, or anything else. Okay? Well, but in biomechanics, when you are tracking the movement, when you are recording the movement, when you are doing motion analysis, we need to record, we need to to record the movement with some device. Nowadays, the most easiest way to do this is using a camera, for example, a mobile camera. Okay, you can do this. But you have always two options. You need something to track, and usually we use those markers. Those markers, when you send some light, some infrared light to these markers, they shine back because you use some specific type of paper that reflects light. Then it reflects a lot of light. Then you use also a filter on your camera, a infrared filter that filters everything but this reflection, that then makes easier to recognize the position of everything. The great problem of doing kinematics in biomechanics is that, okay, I'm gonna do 2D kinematics. And then my first option is take a camera, shoot the movement, and then look at the film in order to see, to get the information. Usually it works.